the wiring diagram that I've used before. It's a simple one, like that, showing you how they need to be connected. You need 2 relays for each window, so that's a total of 4 relays. When that switch operates, that moves the feed from there to there, so the power will come down there and out here to the motor. The other relay is already connected to an earth, and that feeds the other wire on the motor, and that's how the motor gets its power. So currently it's getting an earth from there, from one side, and then earth from here until it's switched, in which case it goes to here, and then it gets power to the motor. The alternative is that this switches to here and it gets power to the motor, and this here will now be deactivated and will be providing the earth to the motor. So it switches over the earth through the relays, and that way it enables the motor to move the window up and then down. I have some generic relays. That's the relay, and it comes with the female connector ready wired. These are 12 volt 40 amp. There are 5 wires. The black wire is 30, the blue wire is 87A, the white wire is 85, the red is 87, and the yellow is 86. There are some small clips either side which you need to push down on here in order to get this switch to come up. So he's looking at the left hand window switch. That's fused to power in, white and pink. According to the wiring diagram, this one here should be blue and white, and this one opposite should be purple and white. I don't think it makes much difference other than which way you press the switch to open and close the window, because it depends on how these are connected here. It's interesting to see that the power in to the switch is actually a single wire joined to 2 wires that then feed the switch. You might think that the connections here, the female spade, you could just pull them off and connect them to these relays directly. Unfortunately, the relays are 6 whatever it is millimeter, and all these connections on here are smaller, 4 point whatever millimeter, so you can't take those directly and connect them to the relay, which is why I might as well use the unit so that the relay's easily changeable. I'm quite a fan of these Wago connectors, at least in establishing whether or not the connections work before soldering them. So that you can just insert them, put the clip down. It's a very firm connection, very firm indeed. And then if you want to remove it, you just unclip it and take it off. So really useful to make sure you've got all the connections right before you go around soldering everything. So on this Wago there's 5 connections. That's the power going in from the fuse box, and that's the power that's now going to feed the relays. There's also an additional spare one there and I'm going to feed that power back to the switch. So I've connected up 87 on both of the relays. I'm now going to connect up the 30s on both of the relays, and that will be taking the power to the motor from the relay. That's the blue and white and the purple and white. Number 30, which is the feed from each of the relays, is a black wire. So I've now connected those up. So we've got power in, power coming out of the relay, which will be going to the motors. The other pair of wires that need connecting from the switch are the earth wires, and they connect to the blue wire, which is 87A on the relay. At this stage, I have removed all 6 wires from the switch, and I've connected it to the relays. What you don't have now is anything that operates the switching mechanism. So all the wires from the switch are connected. That leaves these 4 wires, a yellow and a white from each of the relays. So the yellow is an earth and the white is live. We don't have to worry about the earth ones, we can just connect those to a convenient earth, one of these. Because these yellow ones are thinner wires, you can combine 2 and connect it to earth. That's the black earth coming in, the blue earth going to the relay, and that will provide another earth for the switching part of the relay. The only important ones are these live ones. So it would appear that that is common. So when I switch the switch one direction, that one comes on. That one doesn't. Switch it the opposite way. That one is live. That one isn't. So if I attach power to there and then take a separate lead to the one relay and then one to the other relay from there, then when you're switching between the two, one way will power the switch on the relay here, and then the other direction will power the switch on the relay there. On the switch, it's number 1 to one relay, and then number 3, that one there is going to be common, so I will power that up. And that one there is number 7 on the switch, and that goes to the other relay. This is power, so I'm going to connect that one to there. I'm using these cut-off lengths simply because that female spade connector is the correct fit on the switch. And again, bearing in mind that all this is just for test purposes. So that is now the final connection made, power in to that point there. Power out for the switching mechanism on the relay to one relay, and power out to the switching mechanism on the other relay. And now we'll test it. Doesn't appear to make any difference to the rate at which the window slides up or down, but it is functioning, and that will be through the relays. And the same has to be done for the other side, and I will solder up all the appropriate joints as I take these off, and then leave these relays just lying inside, and that will be perfect.